Welcome back, folks. Rational expressions and equations, lesson 8, rational equations, part 2. So the next step is that sometimes our questions get a little more complicated or we have some issues with our non-permissible values, which will make sense as we kind of work through. Okay, so this example, 3 over x plus 1 plus 1 over x minus 1 equals 2. We solved this one using the graphing calculator already. Desmos. Pretty sure this is exactly the same one. Let's see if it's still in here. Ah, it's not in there anymore. So if we do this graphically again, you can quickly check this using Desmos. You're going to go 3 divided by x plus 1 and then over 1, and that's going to be plus 1. 1 divided by x minus 1. There's the equation, and then I'm going to put in y equals 2. There we go, and there's our solutions, 0 and 2. So our solutions are 0 and 2, right? The x value of this coordinate point and this coordinate point where they crisscross, 0 and 2. So our solutions using the graphing calculator are 0 and 2. So we can fill this in. 0 and 2. But let's do that algebraically. Algebraically, we're going to, or did we do this? Did we do this in the previous lesson? I can't remember. Let's just go back and have a look. Because if we did, we don't need to do it again. Let's look at our examples. Was it our first example? Because I know that was the first graphing example. Graphing calculator, but it was not one of the examples we went through. Bummer. Okay, well, let's do it then. So solving algebraically, remember our process would be get everything on the same common denominator and then cancel off the denominator and then solve for x. Remembering our non-permissible value, oops. X cannot equal -1, +1, plus minus 1. Okay. Now, realize that your common denominator is going to be x plus 1, x minus 1. So I'm going to make this go x plus 1 because that was already there. The 3 was already there. Plus 1 was already there. X minus 1 was already there. Equals 2. And that was over 1. And then what do we have to multiply in? Well, to be our common denominator of x plus 1, x minus 1 gets, x minus 1 gets multiplied here. Common denominator x plus 1, x minus 1, x plus 1 gets multiplied here, x plus 1. And the 2 needs both, x plus 1, x minus 1, in order to be on this denominator. Now that my denominator is the same, I can go, whoop, disappears. I'm going to rewrite this as an intermediate step. 3 times x minus 1 plus 1 times x plus 1 equals 2 times x plus 1, x minus 1. Now, a few steps that we have to do. I'm going to bomb the 3 in here. I'm going to bomb this 1 in here. I'm going to FOIL this first, outside, inside, last. And then an intermediate step will be to multiply that 2 in. So I'm going to get 3x minus 3 plus x plus 1 equals 2 times x plus 1 times x minus 1 is x squared plus, no, minus x plus x minus 1. These will cancel. So it's just x squared minus 1. 3x plus x is 4x. Minus 3 plus 1 is minus 2 equals 2x squared minus 2. Oh, look at that. We have an x squared term. So now we need to make everything equal to 0. So I'm going to subtract 4x, negative 2 is equal to, those cancel, 2x squared minus 4x minus 2. I'm going to add 2. That's going to give me 2x squared minus 4x is equal to 0. And then I can factor 2x, x minus 2, and then solve, just like we were doing before when we were factoring and solving our polynomials. 2x equals 0, divide by 2, x equals to 0. X minus 2 equals 0, add 2, x equals 2. Make sure those are not our non-permissible values. They're not our non-permissible values. Those are my solutions, but I would still need to verify. I need to verify them both, okay? So over somewhere else, maybe on scrap paper, I'll switch colors. I am going to verify. I'm going to verify x equals 0 first. So I go to my equation, 3 over 0 plus 1 plus 1 over 0 minus 1. And we want to make sure that that equals 2. So 3 over 0 plus 1 is 3 over 1. No, that's just 3. Plus 1 over negative 1 is negative 1. 3 plus 1 is equal to 2. So this verifies. And now I need to verify my x equals 2 and do the same thing. 3 over 2 plus 1 plus 1 over 2 minus 1. Well, 3 over 2 plus 1 is 3 over 3. That's 1. Plus 2 minus 1 is that's 1 over 1. That's 1. That equals 2. That also verifies. So this is true. And the good thing is that this was equal to a whole number, and we only had to really verify the left-hand side. But both of those solutions are correct. So we have to verify both to make sure that they are correct. Now, flip the page. Page 402. Consider the rational expression x squared minus 5x minus 6 over x plus 1 is equal to 2. Solve the rational expression by cross multiplying. You don't have to solve by cross multiplying if you don't wish to. If you're already in the habit of solving by making a common denominator, please continue to do so. It makes no difference to me. Just know that you have the choice. Okay. I'm not going to solve this by cross multiplication because that's not the way I've been showing you. So I'm just going to continue doing this. My non-permissible value, I can state already, x cannot equal negative 1. And then what I would actually do with this question is I would factor this question first. But x, two numbers that multiply to give negative 6, add together to give minus 5, that is actually going to work out to minus 6 and plus 1. So this is what I would do for this question, personally. And I hope this works because it's not how I did my notes. I did my notes a little bit differently. So I'm going to say, well, x squared minus 5x plus 6 is also going to factor to x plus 1, x minus 6. Now, just give me a moment. I'm just going to double check to make sure that this is going to work. Oh, I know why I don't want to do this. I don't want to do this way. I'm not going to factor. There's a reason. So I'm going to have x squared minus 5x minus 6 all over x plus 1. It's on the common denominator already. This is going to change to 2 over x plus 1, and I multiply in my x plus 1. These x plus 1s will cancel. Now I'm left with x squared minus 5x minus 6 is equal to 2x plus 2. I'm going to subtract 2x, subtract 2x. I'm going to subtract 2 at the same time. That's going to give me x squared minus 7x minus 8 is equal to 0. Now I need to factor the left-hand side. Two numbers that multiply together to give negative 8. Add together to give negative 7. That's going to be minus 8 and plus 1. So x minus 8, x plus 1 equals 0. So my solutions are x equals 8. Nope, not 8. X minus 1, x minus 8 is equal to 0. So I'm going to add 8, x equals 8. And then x plus 1 equals 0. going to subtract 1, x equals -1. Except that, notice that this solution, x equals -1, is a non-permissible value. That means that I don't have to worry about verifying this -1. It's not a solution. So this is not a solution. So although we calculated for it, we don't have to worry about it. Okay, so question B actually reads it. It says, explain why one of the solutions of the quadratic equation formed does not satisfy the original equation. It's because -1 is a non-permissible value. Okay, so we don't need to worry about it. It's gone. So the only thing I need to verify is I need to verify that x equals 8. So I go back to my original equation. 8 squared minus 5 times 8 minus 6 all over 8 minus plus 1. I want to see if that is going to equal to 2. This is 64 minus 40 minus 6 all over 7, which is equal to, well, not 7, 8 plus 1, that's 9. 64 minus 40 minus 6 is 18. All over 9 is equal to 2. So this is verified. Okay. So sometimes our solutions that we calculate are part of our non-permissible values. We eliminate them from the solution set then. Okay. Question or example 3. Example 3, let's do A. Our non-permissible value is x cannot equal 0. And then my common denominator is I want this on x. This is already on x. And I want this on x. I multiply 1 by x, so this is x squared. And I multiply 3 by x, so that's 3x. I didn't color code this one. Hopefully you can see that. If not, then I'll color code the next one. These will cancel now. I'm left with x squared plus 2x equals 3x. Sorry, that's not 2x, that's 2. I'm going to bring the 3x over so I can factor. Minus 3x minus 3x. X squared minus 3x plus 2 is equal to 0. I can factor this. Two numbers that multiply to 2 add together to give -3. This is going to be x minus 1. X minus 2 equals 0. I take both of my factors, make them equal to 0, and I solve. Add 1, x equals 1. Add 2, x equals 2. Check my non-permissibles. Both of these are not a non-permissible, so I have to verify both answers. So I'm going to verify x equals 1, which means I'm going to get 1 plus 2 over 1 is equal to 3. So my left-hand side, right-hand side, this is 3 equals 3. This is true. I'm going to verify x equals 2. 1 plus 2 over 2, that's not 1, that should be a 2. 2 plus 2 over 2 is equal to 3. Well, 2 plus 1 is equal to 3. 3 is equal to 3. So I did my verification a little bit differently with these questions. This is my left-hand side. This is my right-hand side. This is my left-hand side. This is my right-hand side. Because this is an easier style question to do that with, I just was in my habit. It's a habit that I have. So looking at question B, first step that we're going to need to do, we're going to need to factor this. X squared minus 4 is going to factor 2, x plus 2, x minus 2, oops, x minus 2. So this is going now. My common denominator is x plus 2x minus 2, so my left-hand side does not change. X plus 2, x minus 2. My right-hand side, though, this is x plus 2. This was already here. I need to multiply in my x minus 2. So this is x minus 2. Once I have those all on the same denominator, I cancel them. I'm left with x is equal to 2 times x minus 2. Expand my bracket. X is equal to 2x minus 4. I am going to subtract 2x here, subtract 2x here. That'll give me negative x is equal to negative 4. Divide by negative 1, divide by negative 1, x is equal to positive 4. It is not part of my non-permissibles, which I forgot to do. I forgot to do my non-permissible values. Should be plus or minus 2. X cannot equal plus or minus 2, sorry. X cannot equal plus or minus 2. These do not fit, this 4 does not fit my non-permissible, so I need to verify 4. So I'm going to look at my left-hand side, which is going to be 4 over 4 squared minus 4, which is equal to 4 over 16 minus 4, which is 4 over 12, which is 1 over 3. And I look at my right-hand side, which is going to be 2 over 4 plus 2, which is 2 over 6, which is 1 over 3. Verified. Left-hand side equals right-hand side. And our last example. Example 4. Look, there's a hint. An equation with no solution. So what happens when we get one of these? Okay. So first of all, let's determine what our non-permissible values are. My non-permissible value, x cannot equal 3. My common denominator is x minus 3, so this should be nice and easy. 8x plus 10 on x minus 3 minus 4, and I want that on x minus 3, so I have to multiply by x minus 3, and then equals 10x plus 4 all over x minus 3, all on the same denominator. Those will disappear. That will leave me with 8x plus 10 minus 4 bracket x minus 3 equals 10x plus 4. Expand your brackets, combine some like terms. 8x plus 10 minus 4x plus 12 is equal to 10x plus 4. Simplifying the left-hand side, 4x plus 22 is equal to 10x plus 4. I am going to subtract 4x over here, subtract 4x over here. That's going to keep my x term positive. 22 is equal to 6x plus 9. I'm going to subtract 9, subtract 9. That's going to give me 22. Take away. That's not a 9, that's a 4. Dummy, that's a 4. Can't read my own writing. 4, 4, 4. This should be a 4. 22 minus 4, I'm going to go over here, is 18. Is equal to 6x, divide by 6, 3 is equal to x. Check your non-permissible values. Oh, wait a minute. X can't equal negative 3. So because I only had one solution here, and it is our non-permissible, I simply say no solution. Not solution, but solution. S-O-L-U-T-I-O-N, solution, no solution. Okay. That takes us to the end of lesson 8, checking Stellantis to make sure you know what's going on. And I will see you next time.